During the COVID-19 pandemic, Bibliotech is a suite of tools designed to improve the flow of communications and ideas in the construction industry. Here's a little bit of housekeeping before we get started. If you have any questions during the presentation, please type them into the question box on your control panel. As we have a lot of material to cover, we will answer most of the questions at the end. The title of today's presentation is Daylighting and Sustainable Design, and it is presented by David Montgomery in collaboration with Mike Wetzel from Bravura. An engineer with over 40 years in the exterior architecture industry, David Montgomery is Kalwall's leading regional manager in expertise and trade knowledge. David folds his passion for advanced daylighting techniques and systems with a great sense of humor. This adds up for an accredited presentation that provides education, industry insight, and a few cheap laughs. Without much further ado, I would like to Mike to introduce Bravura, and David will start the presentation.
Well, ahead, thank you very much, Jus. I appreciate this. It's always a pleasure dealing with Bibliotech, and it's great to see how well this has been taking off over the last year or two. As he said, I'm Mike Wetzel, and with Bravura, we are an installing distributor of specialty architectural products based out of Ontario, but we also deal with installations across Canada, as well as part of the US. We distribute daylighting products such as Kalwall, Solitube, walkable glass skylights, as well as large overhead door systems. We also have an interiors division where we distribute modern fold, sky fold, line systems, demountable walls, and smoke guard, smoke and fire curtains. I'm going to keep it short because we're kind of veering off the wrong way, but Dave Montgomery is going to take it away from here. If anyone has any questions, please feel free to jump into the chat pod, and I will try to answer everything as best I can. Thanks, guys.
Thank you, Mike. Welcome, everybody. Those of you who are not familiar with our product, we are these gridded panels that you see on this first project. So that entire facade that you see there, that would be our product. Those are all light transmitting, highly insulated panels. We also include and manufacture the windows that you see incorporated into that construction. The only thing we would not have done on that job are those bump out conditions. That would be a typical storefront type of an approach. Throughout the presentation, I'll be referencing the various benefits of our technology. Everything from a very highly insulated product that produces a very sophisticated diffused light and a very high fire performance, etc. So we'll address all of those. A little bit about the history of our company. We have been around a while, as you can tell by the vintage of these photos. Beginning in 1955, the architectural community really latched onto this product and used it in a number of very notable projects. This first one we reference is the Abbey in St. Louis, Missouri. This was the country's first thin shell concrete structure. There we have some custom tinted panels on the right-hand side, very dark, almost black. Yet on the left-hand side of your screen, you'll notice that the light that comes through our product is that white diffuse light. And the reason for that is inside of each panel, we fill it completely with very fine white fiberglass insulation. So the light assumes the color of that substrate as it passes through. 1964, Philip Johnson used it as a canopy. This was the World's Fair held in New York City. There's actually 85,000 square feet of translucent panels on that project. Very well-known building in South Florida. I used to pick on it because it was not used for many years, but as we all know, it has had more usage recently. Very large building by volume, and we are the primary source of that for daylighting in that facility. While we don't actively pursue the residential market for all the good reasons that I will be reviewing, it's perfectly applicable in those projects as we see here by the Peter Eisman project. This is the Museum for Japanese Art in Los Angeles. It was initiated by Bruce Goff and finished by Bart Prince. Frank Lloyd Wright inspired, as we can see. We are the wall panels in that museum. Our Richard Rogers architect, the Pat Center, another example of how we can incorporate some vision elements right within the translucent facade. More recently, and a number of these are in my area. This first one, the O'Hare, I should say the American Airlines hangar at O'Hare Airport in Chicago. You notice the top, let's call it third of the facade is all our typical translucent panels. And we also provided that band of dark panels right below our application there. That was actually an add to the scope of work brought to us by the FAA that needed less reflectivity from the metal panels right below us. And as you can see on the bottom right-hand quadrant, very well balanced daylit space. Blue Origin, this is the Amazon component to the current space effort. Again, showing our ability to introduce color into your project. This is an interesting project. You can recognize our product there. We're actually only transmitting light on this particular facility in the very top row of panels. The architect chose us for the balance of that strictly from our insulative capability. So we have an R10 translucent panel that is in fact transmitting light in the very top row, but the balance of that is simply superimposed onto a block wall. So kind of a unique application. Very nice boutique distillery in Columbus, Ohio. This facility began with the concept of a conventional metal panel approach, and we were called in to do some punched opening daylighting. When the designer learned of our ability to span about 3 times the dimension of a metal panel, it allowed them to remove a significant amount of structural steel. And the result is, as you see there, this became an award-winning design, and we did provide all that glazed area that you do see there. So that does represent about as much glazed area as we typically would get into, but it does show our ability to combine all of those elements. Amager Resource Center in Copenhagen, the BIG group. This is a waste to energy facility, basically burning garbage to produce electricity. Upper right-hand quadrant, we provided some special usage explosion venting panels to release any unwanted buildup of methane gas that would be in that facility. And bottom right-hand quadrant, you can see very typically how much money they have left over. In Europe, they had enough to put on the ski slope that you see there. Of course, I'm sure that happens often as well in Ontario and etc. So this will be a registered presentation with the AIA and OAA. You'll be receiving credit for being with us today. There's the list of the official objectives. Basically, we will be talking about taking advantage of free energy in the form of sunlight and then transforming that sunlight into usable, controllable, measurable daylight. To begin, we'll review the basic building block of our technology, which is the 2 3/4 inch thick insulated translucent panel. We begin by constructing a structural grid core. And in that, the grid cores are actually made up of very small I-beam sections. So then within the voids created by that grid pattern, we then place various density of very fine white fiberglass insulation. And that insulation provides much of the insulative value for the product, as well as diffuse the light itself. And then to those flanges of those I-beams, we laminate under heat and pressure FRP facings, fiberglass reinforced polymer. The net result is a very lightweight, weighs less than 2 pounds a square foot, yet very strong composite panel. We do manufacture the panels in standard dimensions of either 4 feet or 5 feet wide. You can make them any portions of those numbers, nothing wider than 5, however. But then we make very tall panels up to 20 feet in length. So you'll see throughout the presentation many examples of significantly large panels. To begin with, we'll address what's different about a space utilizing translucent materials as opposed to one utilizing a conventional glass type skylight. So if this were a glass skylight, the source of the light would be whatever that light reflects off of after it enters into the space. So it could begin the day, as an example, on the wall to the adjacent left, and then as the sun moves, that source of light would then move within the space. In a translucent application, the source of the light never moves regardless of the sun's position. And it's always the inside face of the panel itself. So essentially, translucent materials behave very much like a light fixture, which then allows the designer to be very accurate in the positioning of the apertures, as well as sizing those apertures in order to have the best well-balanced result. The same thing would be true if it's a vertical application or a wall. So the source of the light is the inside face of the panel. Our product does push light about 2.5 times deeper into the space than what you would realize, say, if you had just a typical low-E type of glass product, where very much, the vast majority, I should say, of the energy is within a small percentage of that space. And we are talking about a translucent material, meaning not opaque and not transparent. So these next two slides are going to do a great job of demonstrating what I call the power of diffuse light. So what we're looking at here is a nurse's station where presently there's just an opening in the roof where we are about to place a skylight. Notice the high concentration of the solar energy in a very small area. As we place the skylight over that same aperture, the same amount of energy is now doing all of that daylighting. So this, in a nutshell, is the essence of the Kalwall product. In a similar fashion, we have a glass type skylight here, producing that amount of light. And notice the shadows that you would get with any type of direct transmission of light. When we transform that into our product, you'll notice that we have a comparable amount of light in the space, yet all of those shadows have been eliminated. So this is another fundamental aspect to our product, is because we remove the variance in light around you have less eye fatigue. So this is fundamental to our product as well. In our industry, we seem to transfer very low percentages of light. You know, most of our projects are actually between 12% VLT and 30. And at first, it may not seem like it's adequate until you take into account the previous slide showing you the power of the diffuse light, as well as taking into account the amount of available light on a typical day. You can see you don't have to have a high percentage of transmission to accomplish your daylighting objectives. So here's a nice chart of target levels of light from the Illumination Engineers Society of North America. You can read the various foot candle levels there. Whatever your project requires in terms of light level, we can accommodate it with our product. Some guidelines for daylighting. This happens to come from the wood window industry, but any reference you would look to in particular would agree that translucent materials do a great job of eliminating glare conditions within the space. So you'll see this product used very often on indoor athletic facilities, libraries, classrooms, any place where you're using your eyes in a significant manner. The Department of Energy in the U.S. has conducted a number of studies on the potential benefits of daylighting, recognizing that the design principles involved, it's always best. Item number 3, I always like to focus on. It's very important to have the aperture in a wall application as high as possible on the elevation, because that will result in that light transmitting the deepest into the space. So you're getting the best usage out of it. And the other thing that's fundamental is horizontal apertures do present even distribution of light from the exterior toward the interior, as opposed to vertical columns or shafts of fenestration that do in fact present very distinctive semicircular patterns of light, thereby creating dead spots between those areas. And then also recognizing that direct beam sunlight is not considered to be true daylight because of the real probability at some point in time, at some point in the season or time of day, you could have a glare condition within that space that could actually render that space unusable. More and more, there are studies being done on the physiological effects of daylighting. A lot of the new metrics with regard to design criteria are taking this more into account. And essentially, the studies have shown that we're not getting enough daylight in our day-to-day lives, resulting in a term called biological darkness. So this is becoming more and more fundamental to our design. The light that we do transmit does so, and we have full transmission throughout the visible light portion of the spectrum. And importantly, none of those individual frequencies are altered. So you get accurate color rendition. So depending on who that client might be, color accuracy could be very, very important to them. And this product does give you that. At the same time, we do filter out virtually all UVA and UVB. So hence this product has been given the term museum quality daylighting. If you are working on a project and you anticipate having a significant amount of plant life or perhaps even animals like in a zoo or botanical garden or that sort of thing, there is no issue with plants with respect to photosynthesis as that occurs in the center of visible light. And of course, I mentioned we have the full spectrum covered, so that's not an issue. Animals, in fact, however, do need an amount of UV. So if you are working on a project like that, you would have to incorporate some other materials in that space that would in fact allow for that UV transmission through those apertures. We always like to cover that to make sure everyone understands. In terms of workplace productivity, if you consider not having to fight glare conditions and variant light levels around you all day, I know many of us have struggles with the computer screens, right? So you're always doing things with that. Then your productivity, if you're not having to combat that, your productivity goes up. You're less tired at the end of the day. You're more apt to be accurate in your work, etc. So it has a very positive effect on productivity. In the educational application, both students and teachers benefit from the improved environment that does result in higher test scores, as an example. In the retail world, obviously, vision is always going to be, the primary method of daylighting, if you will. It's also vision of what's for sale. That'll always be the same. But perhaps a combination of some translucent materials used along with the transparent materials will allow you to do things like better control late afternoon excessive solar heat gain, as an example. So the combination is probably a good idea to consider. As I mentioned earlier on, a real mainstay of our work is in the indoor athletic facility realm. So in addition to avoiding bad glare conditions, which is a bad thing to have in those environments, our product also has a superior impact resistance. So it gets along better, is one way of saying it. It gets along better with the activities in the space. So most projectiles are going to bounce off this material without incident. So we do a lot of that sort of application. And we have a few examples shown here. This is an interesting gymnasium. You'll notice that there are no electric lights even available for usage. So it's an unusual place. It happens to be a day school. They're not open at nighttime. That's how this is a possibility. We like this image for a couple of other reasons. Notice how the vault is not exactly centered on the depth of the room. It's pushed away from the exterior wall a bit, right? Taking into account the value of that wall fenestration there. So this is a good example just to make the point about how daylight modeling can assist the designer in positioning the apertures in order to have the best well-balanced result. And the other very important thing about modeling is it helps you size the apertures. And that's where the cost is. So if you can utilize daylight modeling early in the process, you can have a real value added to your design. And I always like to point out that, you might think this is in Texas or someplace way down south. This is actually in London, England, famous for rainy days, right? So this is what can happen. So now that we have a nicely daylit space, in order to achieve that, we had to poke holes in the energy envelope. We have SB10 now in Ontario, and these things are real. You design and spend a lot of time with your design, and when you get it reviewed, you find that you have to make adjustments due to the ever increasing challenges placed on us with regard to that. So our product, if we don't put any insulation inside the panel, it'll have an R of about 2, very similar to basic 1-inch insulated glass. As we start to introduce the fiberglass inside the panel, the least dense will give us an R value slightly better than 4. The next density, the R goes to 7, and then to 10, and then to 12. And then by changing out the insulation, instead of using the fiberglass, we put in an aerogel material. I'm sure some, if not all of you, have heard of that type of material, granular. We fill the panel with that and we get an R of 20. So you can see that obviously this is a very high performing daylighting material. So this is what we do: highly insulating, high quality diffuse light. This is a nice graph showing us that we get the benefit of the sun during the daytime, which makes perfect sense. And the reason why that's important is we get the benefit right when we need it, because that is the time of peak demand for electricity. This is what makes daylighting a very efficient method to improve the long-term viability of your design. The financial benefits of daylighting, user productivity, I mentioned earlier, that is a very big thing. Reduced operating costs is another one. So if you can show your client that by your design, they won't have to turn the lights on 40% of the time, or 50%, whatever the value winds up being from the daylight model, then you're adding and able to correlate that to direct operational cost savings. Here we have a nice climate zone map, basically to point out that there's nothing north of the United States, as it turns out. That's all tuned in. I don't know there's something missing there, but anyway, in the United States, we have what we see here. And the point we're making here is, as impressive as our product is in zones 5 and above with regard to R value, we're equally impressive in zones 4 and below with respect to solar heat gain values. We can actually get down to where we have single digits of solar heat gain, which you won't find in many other types of materials. When you work with our product, you will find these graphs that we're talking about and charts basically showing us the optional face colors on the left. And as you move from left to right on the chart, what you're doing is increasing the density of that inboard fiberglass. So as you can see, as you improve the thermal performance of the product, there is a decline in the amount of light coming through, which makes sense. It's less dense. Then you get to the highlighted column, and that's the aerogel product. You'll notice that that light level does jump way up, almost 3 times as much. And so that is the relationship in how we work on buildings. And on the right-hand side, these are the solar heat gain values I mentioned. Bottom right-hand portion of that, you can see as low as 4% solar heat gain. And sometimes solar heat gain is important, not just for the folks in the south, but you don't want direct beam sunlight on your ice skating facilities. I mentioned earlier, lightweight, less than 2 pounds a square foot. The benefit of that might not be immediately apparent to you, but if you consider this product, and let's say you're going to do a ridge type skylight, and this material's 2 pounds a square foot, and a comparable glass and aluminum product is going to be 25 pounds a square foot. So then what is the cost of the curb construction as an example? So just from the fact that the material is lightweight, you save on other aspects of your construction design. Bottom right-hand portion of the screen now, that is a normal panel. Nothing special about it. A lot special about the people willing to stand on it, but we won't go into that now. But you'll notice that there's 2,700 pounds of load on something 2 3/4 inches thick. So it's a tremendous achievement with a composite material. Safety and security is very important. To begin with, the material is shatterproof. So if you hit it with something strong enough to reach the maximum strength of the face, all you have is a little crack in that face. When you do the same thing to a piece of 1-inch tempered glass, as we all know, you have a gigantic void in the building that you can just walk in, and you have to be careful where you step. That's about the only concern there. So you can, with our product, you maintain the security. You can repair or replace that product when it is a convenient time. You do not have an immediate security breach. Very important. Additionally, if someone were to mark up the panel with spray paint, etc., the material is very easily cleaned. We do have a couple of specialty application products. This is the blast resistant or anti-terrorism force protection. You're typically going to run into these on government or federal type projects where you're making that facility what we call hardened, so that it blast mitigation type design. Now, in this criteria, the pass-fail is the material must not become particulate if there is a blast outside of the facility. It must not become particulate, causing loss of life for the occupants. So because our product is shatterproof, all we need to do is control the amount of deflection on the panel. And we do that by advising the designer where we need structural steel support behind our product. But very importantly, we don't have to shrink the size of the aperture, which is the result when you are trying to work with a glass type product. Another specialty application is explosion venting. This is the ability to design the system. If you have a client that could have an explosion as a result of their operations, pharmaceuticals, etc., food processors and the like, these systems are designed to release any concussive force from that event off the building. The panels basically vacate the opening. Per detail 1 that we have shown there, the panels are tethered to the building with a high tensile cable. They basically release the force of the event and then hang in front of the wall, and they actually can be replaced after they have done that. Windborne debris, if you have a project near the coast, and you need to be compliant with that, we have all of the required testing, etc., up to and including the large missile D component to that requirement. Skylights or things on top of the building need to be safe for people walking around. It is amazing to me how often it seems like once a year you hear about somebody falling through a skylight, and it's not always a pleasant outcome. So this is a serious matter. The ASTM E661 test criteria is basically a concentrated load on a small diameter disc area, and it's meant to simulate the weight of a person, if you will. Now, most, if not all, materials meet that requirement in a non-fire condition, so that's not difficult to do. But the issue is in fire conditions, polycarbonate skylights and acrylic skylights actually melt out of the openings. So they create a significant hazard for fire and dragging hoses across the roof. Right? So they require, in the top photo you see there, they require either those cages around from the exterior, or another alternate method is to put under screening on them. Now, if you are working with those types of products and you have this condition to contend with, my recommendation is the under screening as opposed to these cages. And the reason why I say that is that sometimes the fire that might be referenced here could have started a block away, and you have a burning ember. Now, if you have a burning ember land on a polycarbonate skylight or acrylic skylight, it will burn through that material very quickly and introduce flame into the building if you use the method shown there, the cages. That'll do nothing to stop that. Whereas the under screening will accomplish that. So I do recommend that method if you have that condition. Our product does not require either of those safety devices because our material does not become molten in the fire. So the result of that is you need no additional security items, and that will save your client a significant amount of cost, depending on how many skylights you have on your project. So keep that in mind. IBC, OBC, UL Canada, tested and listed systems. So we have an S102 OBC fire performance rating for our roofing systems, UL Canada Class A roof. So we are allowed to be 100% of a roof in a sprinklered condition. In the vertical plane, because we do have some combustibility, as low as it is, it's still some. We are not non-combustible, is another way of saying it. We are restricted. In Canada, we reference not the number of stories. Okay, so our product is allowed to be used up to 2 stories. That measurement or mathematical dimension, it varies on the design of the facility. In the States, IBC, it's just a hard number, 75 feet from grade. So it's a little different approach, but it accomplishes the same thing. I'm sure we'll have more questions about code at the end, so I'll just move on from this at this point. Sustainability, obviously, for all the things I've been referencing, highly energy efficiency, daylighting in views. So we've been part of the LEED effort from the beginning. We've done hundreds of projects. This is a LEED Platinum project, Dunbar High School in Washington, D.C. Very significant skylight there. This was our first net zero project, the Carbon Neutral Energy Lab, way down in Georgia Tech. Now, keep in mind, down there, they care not much at all, frankly, about R value. They do, however, care a lot about solar heat gain. The solar energy is all about what they battle down there. And because we have the ability to get down into those very low levels of solar transfer, you can see the result of how much of that design we became. So the majority of the facade. Living Building Challenge design criteria. This is one of the first of those in the States. The Willow School, you can see our product there. Committee on the Environment, top 10 winner. Yale sculpture building. On the right-hand side, it just looks like a conventional glass and aluminum application, but a closer look at the diagram upper left, it's actually a trombone design where we have our R20 panel inboard of the outboard glass and aluminum curtain wall, creating the trombone design, allowing the energy within to be utilized. Here's one not too far from where we are today, or where you are today, right? Over in Hamilton, a top 10 award-winning project, the CanMet Materials Tech Lab. I usually like to point out on this photo that, we always think about wall facades as being, linear and, modules, taller rather than wider, that sort of thing. With our product, and part of that comes from the necessity, glass becomes limiting. When you start getting really wide with glass, because of the dead loads, they're limited with regard to that. So because our product is so light, it doesn't bother us at all. So here we have 14-foot tall panels that are just on edge, right? And now we just stack those lightweight panels up, and it does present a significantly different aesthetic on the building. We have no problem in transferring the dead load from those panels because, again, so lightweight. So this is another unique aspect of our product. Getting into the 4 applications of how we are utilized: facades, sky roofs, skylights, and canopies. Facade and a basic wall application. I love this photo to demonstrate, where our strength really is. So again, big panels. So each one of these panels is 5 feet wide and 18 feet tall. That's one piece of material. We're spanning in excess of 14 feet in between supports, and keeping in mind 2 3/4 inches thick. This is the uniqueness of our product. Something like that, we are going to be considerably less expensive than a conventional aluminum and glass solution, and many times more energy efficient, depending on, of course, the performance of the glass infill. The product is applicable across markets, across design, aesthetics. This project here does reference, or I should say, show us the largest panels we do make, 5 feet wide and 20 feet in height. Okay, obviously we're tying back at least 1 point in this. We can't span 20 feet. We span 10 feet. So we've got some support there, but it just kind of gives you a sense of how large we can make these panels work. Now on this project here, you'll notice looking at the grid that's missing the horizontal grid. So throughout the presentation from this point forward, you'll see some variation on the typical rectangular grids. So this panel here with the vertical grid only, it's not as strong as the others. It does come with some limitations, and that limitation is 10 feet maximum panel size. But there's nothing to stop you from stacking those 10-foot elements, and I have a project that shows that coming up in just a few minutes. Here we are accenting the horizontal line. We also produce those louvers that you see there. Kind of a throwback design, the staggered grid. I think that was big in the 60s. If all of those of you who can remember the 60s. I'm probably the only one on the call. That's all right. Then we have we are becoming more of an architectural statement, I must say. We've always been the high performance product in the back, but now architects are starting to utilize us more in the front, because one of the things that our product does very well is when backlit at nighttime, it really puts a positive statement on your design. We can make panels that result in any shape you can imagine. No issues with that. Arched heads, clear stories, very typical applications. Segmented vertical walls. These are all flat panels, just with the breaks at each mullion to mullion connection. A couple of different face sheet colors are utilized here. We can provide a truly roll-formed product, as we see here, minimum radius of 3 feet. But again, bend the panel and then stack these up, transferring load back to the columns that you see there by others. There's the American Airlines hangar again, just to kind of give you a sense of scale. Each one of those panels is just under 16 feet wide. Good example of retrofitting an industrial space into a workspace or educational space. Backlighting is a feature that people like to do with our product. This would be an aftermarket approach, but we'll provide whoever you are having handled that treatment with reflectivity values and maximum temperatures, etc. But here we have vinyl appliques on the #1 surface of the panel, and then LEDs that are not in the panel itself, but just inboard of the panel a little bit. And as you can see, the light does transmit quite readily in the panel. As I mentioned, 10-foot maximum panel with that vertical grid, but again, stacking those up. Keeping in mind, we would need structural support behind every panel to panel connection, something at the corner, but all the rest of the loading is being handled by the panel itself. The windows we manufacture are both architectural and heavy commercial, fixed, project in or project out, all designed to handle 1-inch infill. At the far end of this practice facility, you'll see our product down there. The red that you see is actually a result of us coloring the inboard fiberglass. So nothing is done on the exterior sheet itself, but the insulation inside the panel in each one of those individual cells is colored. That color can be any color you would like. We will custom match that. And it does give you a significant ability, to design with color. We have the ability to unitize the translucent panel with our windows that we manufacture and ship in an assembled form up to 35 feet in length. And notice the other thing, one of the things about our products also unique is with a glass and aluminum solution, you have to start and stop things at spandrel and parapet conditions, because you have to switch up the glass and that. Because our product from the exterior during the daytime reads all uniformly opaque, we can just run right on past those conditions. You don't have to start and stop it, which makes it an easier installation, makes it a cleaner design. And the only time you would even notice that you've done that would be at nighttime, as we see in this photo when backlit. Good photo of the interior of our product showing the nature of our window, that it's very flush with the inside of the panel itself. Typically you put a window in these things and you're going to have a shelf there. This is all in the same plane. Sometimes that has real benefit in the manufacturing or in the industrial setting where they don't want things to be built up, collecting dust and dirt and that sort of thing. So that has some inherent benefit to it as well. Many of our projects do have some element of vision incorporated right within the translucent panel. There's a mixed-use facility in Portland, Oregon, where we have retail on the bottom, parking in the center, residential on top. Our product is being applied in the center part, which is the parking area, translucent panels, and then also louvers that you see there. That's the dark area. We have the ability to manufacture panels that can adapt to any of the conventional curtain wall manufacturer systems. We do that by affixing a 1-inch deep channel all the way around the panel that will take the place of the glass in the glazing pocket of the system. The only caveat there is it does need to be a conventional exterior glazed pressure plate system on all 4 edges, like a 1600 wall if you're thinking Cornier. I have not managed to remember Lumicore's number of the similar manner, but the point being, it can't be an inside glazed product, and that's because of the thickness of the panel. We're going, the balance of our panel is going to project inboard of the glazing pocket. So you can't do any of those other things, but it can go straight in from the exterior. And by having that ability, though, you can have a real positive effect on the thermal performance of the facade, as well as the solar control of the facade. So these things can really help you out. There's been many cases where design that was going through the final approval and didn't pass the energy component, where the architect was able to simply pull out some previously thought of low E glass with minimal R value and replace it with this much higher thermally efficient material, thereby the design flies and not having to go through a redesign. So that can have a real effect on things. Here's some window replacement applications, again, allowing the panel to go right on past the slab. And adaptive reuse applications. Then up on top of the building, sky roofs. This is a term that we use, and we hear skylight, sky roof. The reason why we say sky roof is because we can be 100% of the roof, and because of some of the characteristics of how we handle that with an overlap joint that is like a shingle design. This is where we get the sky roof application. And it's a very versatile product with regard to that. We can be a self-supporting solution where we take care of the structural component of the element from the top of the curb up, let's say, or we can clad over existing structure. And the bottom right-hand quadrant, we can actually make removable skylights. So a lot of capability with regard to that. This particular application here is one of the more popular self-supporting ridge roofs, where all you need to do is provide us a perimeter curb, and everything from the top of that curb up is all our system. No need for any structural support at the ridge or down at the rakes. The panels are doing all the work. So this is really taking advantage of what we do. Reduce the amount of structure required by others. And the net result is, as you see, they're very clean, finished product, providing a very uniform amount of diffuse light. Then we roll form that into a vault type application. We pick up a few feet of span capability up to 25. I failed to mention the previous one. Let me go back a second. Yeah, the maximum span of this configuration is 20 feet in width. When we get beyond a 20-foot wide application, we are then going to provide an aluminum substructure, and it starts to remind you a lot more of a conventional glass product, but up to 20 feet, the panel's doing all the work. Here we pick up a few feet in span due to the benefit of the arc. So this is up to 25 feet in span capability. Custom sky roofs. Tell us what the loading requirement is, and we will advise you where we need support. Not uncommon for us to span 10 feet in between supports. So again, really taking advantage of our capability. Very nice terminal in South Bend, Indiana. An example of a high performance roof. This is 40 feet wide, 640 feet long, and an example where we are only transmitting 12% solar heat gain. If that value is up into the 40s or the 50s, it would have a completely different result in reality on the mechanicals of this volume. It's a very large volume, very efficiently handled by our high performance materials. Lots of examples of skylights and sky roofs. Here's a nice one combining translucent as well as a significant amount of vision in the vertical plane there, and that kind of gives you a dynamic space. But again, allowing our product to take the brunt of the solar energy, not forcing that on the lesser performing materials. Again, you will have light be pushed deeper into the space as a result of the source of the light, as mentioned. When we do reach the limit of what the panel can span, we then, as I mentioned, will start to look more like a conventional glass and aluminum solution, where we then run the panels perpendicular. Up until this point, all the panels have been running down the slope. Now, when we reach that limit, we actually use them as purlins and have them run transverse to the slope. And by doing that, we can do apertures over 100 feet in width. So very, very capable. And this is a turnkey solution for you: engineering, structure, cladding, etc. Here we have a project we're proud of in Manhattan. This is all an in-house designed solution, engineering, structure, etc. And this is a seismic design where it's about an 85-foot span. and seismic considerations given. We have over 30 inches of total movement in that, and all those trusses are actually aluminum, not steel, which is unusual. Aluminum trusses, architecturally painted finish, so it's a low maintenance solution. So, and with this group, again, larger skylights. Because we are providing, excuse me, the structural component, should your client want to have some element of glass right within that, we can accommodate that with this. Okay, so that. Also, an alternative solution for this is to lift these translucent elements up a bit and introduce a short vertical aperture, putting some vision in that condition, which will allow that connection to the sky that people seem to gravitate toward. Here we have our ability to provide you with an entire building, okay, pool enclosure, but sometimes these are used for other things. We have the need to have additional space for educational purposes, etc. So we can give you that ground up solution. Again, these are all aluminum structural elements. Here we're showing you also our ability to have the panels operable to ventilate that volume. We do a fair amount of water and wastewater treatment business. This is an extremely corrosive environment. Anything with iron in it does not do well. We have none of that in our product. All corrosion resistant finish on an aluminum structural element, and then the FRP is completely non-reactive. So we do, again, a tremendous amount of this type of work annually. We also, as you can see here, excuse me, can provide you with the ability to have these removable. We design lifting lugs into them right at the factory, which is an unusual thing to be able to do. If you try to do that with glass and that sort of thing, you're going to have a lot of broken glass. So the flexibility of our product allows this to be a reality. We do have a short list of what we call standard product skylights, where you work with predetermined dimensions in terms of sizes, and the engineering is already done. So it's feasible to give, just give me one of these pyramids, and you're not paying for the design component to that. This would probably be, if you do have a residential type of a client, would be where I would start in terms of introducing our technology to them, again, because of the simplicity involved with this aspect of it. This first type of skylight is a single panel, either 4 or 5 feet wide. 4x4 is the smallest, 5x5, but then in even foot increments all the way to 20 feet in length. So when you get this product, it's an uninterrupted surface, right? There's no joints anywhere to have anything bad happen. The panel ships from the factory with its own perimeter frame attached to the panel with welded corner construction. So you are literally taking the finished product off the truck, and then you would place it onto a prepared curb that would be there by others. But very cost effective. All the same performance criteria are available, and the labor component is very low. So very efficient way of introducing the same high quality light into your space. Pyramids are also standard from 4 feet square to 20 feet square. Even foot increments pre-designed at 27, 33, and 45 degrees of slope. Standard product, and there's the interior of that. And geo roofs from 8 feet in diameter to 24 feet in even foot increments, pre-designed at 15 degrees of slope. They are also a standard product, and there's the interior of that. Okay. Last grouping, canopies and walkways. This is one of the faster growing segments of our product line. This material is extremely useful in these applications because the same things fall on the tops of our canopies as a glass type solution. Only difference is you're never going to see that, right? Glass type canopies, it picks up everything. So it may look beautiful for a while, but it won't for long. And that's just the reality of that. So now if you throw a book out onto one of our canopies, you'll see a shadow line. around that book as an example. But even twigs and sticks and things like that, they don't even show up. So it's very low maintenance. We do suggest they be hosed off every 5 years or so because they will collect things. So it's low maintenance. We do have superior span capability, and I think a very important part and aspect of our product is our ability to bounce light off the underside. It does it in an extremely efficient manner, and by doing that, as you can see in the top center photo, this is a train station and not necessarily the best part of town. And if the parking lot is to the left of this photo, and if you're getting off the train and finding your way to your car, you want that as your that we're looking at there. You want that as your environment. Very well lit space. And notice the canopy on the right-hand side of that photo. Even though we are putting a significant amount of light on the underside, we're not allowing that light to significantly go up and create light pollution, which is another important aspect to design. Our ability, again, to span allows the cost of the structural component to be reduced, is another very big, important aspect to our product. Here's another example of what I was referencing about lighting these things up. In addition to that safety factor, you're also putting a beacon on your facility, making it very, very obvious where the entrance is for the facility, etc. So this kind of gives us drill down a little bit deeper to see how significant the safety and lighting aspect was on that train stop there. And we also make vaulted canopies for the same type of application. We see a lot of those around. We also have the ability to provide you with a single source turnkey solution, ground up, engineering, structure, cladding, gutters, downspouts, accommodation for conduit. So a real turnkey capability for you, like we see here on this bus terminal facility in Columbus, Ohio. I like to refer to this project as the 5-day job. Total time on site, 5 days. The materials are arriving pre-finished and prefabricated, knocked down. So it's basically assembly only. So again, a very, very efficient way to put a canopy on your building. And we do all sorts of these designs, including the structure, as we see here. Walkways, we've all walked through those, what people call hamster tubes, right? Hot in the summertime is an understatement. So our product will keep the unwanted solar heat gain out, while at the same time we are providing some capability of vision. And even without vision, as we see here, it's still an open, airy feel to the volumes that you will be creating. Okay. And that's the extent of the official presentation. We do take a minute always to address what many people are thinking with regard to anything using polymers, etc. It looks beautiful today. What's it going to look like in 20 years? That's a very reasonable question to have. Since we did begin in the 50s, you can only imagine how well in advance the design was from the technology that existed during the day in terms of the chemistry, right? So, there's not a whole lot of older projects in Canada, but, you can be in the States and see, this product that's been on the building since 1960 or what have you. And, it might be an industrial facility and the place is still operational. And it's part of our duty is to try to sell them, a newer, improved, and all that better looking product. But the unfortunate thing is the materials don't leak and they still allow light through, even though they don't look that good. And so that's one of the reasons why you still see some of the older projects around. But during the 80s, we put films on this material that helped a lot, but those films could wear off over time. So what we had to do was make our own facility, design our own matrix of polymers, and produce our own fiberglass face sheets. So we got away from all of that, heritage stuff or legacy stuff, right? So today's product is an extremely color stable product. We tested in South Florida alongside of Kynar people. I always like to use them as an example because everybody is well aware of their capability, etc. Numerically, our product is on par with their very highest performing coatings. So that means it doesn't mean it doesn't fade at all. It does, but your eye won't be able to discern that. But we tested it with a spectrometer, and numerically, it's almost identical. So it's a very highly color stable product today. I've recently I've been finding myself saying it will be one of the better performing products that on your building. I mean, it just will be. So in terms of colors that are available, you've seen a lot of examples of crystal and white face sheets. Here's some examples of some pastels that we've had for quite a while. But recently, we've also added some other grayscale type face sheets in order to kind of modernize the feel a bit. A lot of this does come from, there's a lot of metal panel work going on, facade work going on, and a lot of those tones are in this range. We've also opened up the toolkit with regard to available grid patterns. We saw a few upper left-hand ones, but all of these are available.
David?
Excuse me? Yes.
I think we're at time, and I wanted to be respectful of everybody's time, and I just wanted to make sure that we had enough time for questions.
Absolutely.
Let's
do. Well, I'll leave this slide up and fire away if you have some questions.
Yeah, I don't know if anybody has some questions, but there was one question that I wanted to ask before everybody left was if you could touch on the pros and cons of fiberglass materials versus, say, polycarbonate, because those are kind of like two, I would say, competing technologies that are out there, but I'm sure there are pros and cons to each. So I don't know if you could kind of give us some feedback on that.
Yeah, I can certainly do that. The primary difference between these two types of technology you reference is our product is thermosetting, meaning once the polymers go from a molten state into a hardened state, they remain there. So they go through the process of being formed into a sheet. Once that has a heat involved, once that is cooled, that hardened product never goes back to the molten state. That's called a thermosetting material. Polycarbonate and acrylic materials are thermoplastic materials, meaning they can go from molten to solid and then back to molten again. So where that and we'll do that, and whether or not that can repeat, I actually don't know if that can repeat more than the one cycle that I just referenced. Where that comes into real significant focus is life safety issues on a building. So as an example, if you have a canopy outside of your building, and let's say there's something going on and there's a fire in a building and people are exiting the building, as an example, and some fire comes out and lands on something on fire comes out, lands on the polycarbonate material. It will very quickly burn through that material and during that process, that polycarbonate canopy will become molten and drip molten drops of the polycarbonate on whoever is underneath that. Additionally, as part of that occurrence, the polycarbonate actually becomes fuel for the fire. Our material, when introduced to flame, does have a combustible aspect to it, but as soon as you remove that flame, it self-extinguishes. Okay, we have the ability to produce 1200 degree Fahrenheit fire on the face of our panel, and after an hour of that flame, have no flaming through that face sheet. So in terms of fire performance, the two are in completely separate worlds. All right. If I would say something positive about polycarbonates, I would have to say that they are available in many different colors. A lot of times, color is important. So they do have a significant ability to provide many different colors. I would question the color stability, however, of that material over the long term. I would check If you're considering that, if you have a project that has been in the world for 15 years, how does it look then? So it's not about what it looks brand new. What does it look like in 15 years? So those are the things. In terms of thermal performance, they can do a fairly good job. They can't quite get to where we are in terms of that, but they can provide some significant R value, in excess of an R5 as an example. So that's pretty good. I'm at a loss for maybe other comparative. Do you have any specific questions about a characteristic of that?
No, not specifically. I just knew that there were two competing technologies. Somebody else had a question in the chat, and I think Mike has partially answered it. Can you speak to the installation of Kalwall in extremely cold environments?
Sure. The materials come factory fabricated for the most part. We do allow limited field trimming of the framing system, and that's to give some variance, flexibility on site, because things are never 100% perfect, oddly enough, right? And so everything is a tape set, so the tape is already pre-installed onto the frame. You take off the protective paper, like in a lot of different products, and it's ready to receive the panel. So in terms of the installation aspect, I would say this. Fundamentally different to the glass and aluminum industry that typically designs things with like a half-inch shim, around the frame. They shim all their framing in. We are significantly different than that in that our framing system goes tight to the surround. We don't have that shim space anywhere. We seal behind all of our framing systems completely. So all of our framing, we call it set in sealant. Okay, so we don't have any exposed sealant. When you work with any type of product that has exposed sealants, then they become susceptible to UV over time. We don't have that. So additionally, that would be that. And again, the fact that we can install large panels, 3-4 times the size of a piece of glass, let's say, your labor productivity is very much enhanced with our lightweight material.
That's perfect. I think somebody else was talking about cost per square meter or cost per square foot of the panel, and I think Mike has provided an answer. But if you could also speak to that, that would be great.
Well, Mike, I have to defer to Mike because.
Okay. So Mike, you speak to it then.
Because he has to remember to cut me in on this stuff, and so I don't dare.
Oh, please!
Right.
We average about $700 per meter square with union install here in Ontario. If it's in a very remote location, such as an extremely cold environment, the naval facility that we did in the far north, where there's not even any ice roads, it was only shipped on Navy ship up to there. Well, obviously installation kind of goes up a bit higher. But we sort of average around $700 a square meter. Larger projects, that's substantially less. If you're looking for half a dozen, half meter by half meter punched openings, then it's going to be a bit more when it comes down to it. But I would say on average about $700 per meter square, which is a lot less than any other type of curtain wall system with a basic glaze, and substantially less when you get into products that actually compete with it, such as like a triple glaze product or other translucent glazing materials. Right. One of the other big things that we've noticed, we did speak upon polycarbonate, and just before the presentation, Juice and I were sort of discussing supply chain issues, and luckily Kalwall, knock on wood, hasn't had any supply chain issues, mostly because they manage their own supply chain. They've been doing this for 60 some odd years. Right. They kind of call the shots there. Other products such as polycarbonate and acrylic currently do have a very long lead time. One of my colleagues just had a job switched over that was polycarbonate over to Kalwall. because the product was going to take about 5.5 months to ship after shop drawings, and the building just couldn't wait this long. So we do offer very prompt lead time. Currently, fabrication, once we have all the drawings done and all that other jazz, is only about 4 to 5 weeks at this time right now. I mean, Kalwall's a larger facility. There's about 500 employees there. It's all manufactured in New Hampshire. It's kind of, it's our climate, if not a bit colder than Ontario. And then they ship it all themselves. It leaves on the Monday. It shows up in anywhere in Ontario on the Tuesday. Or if we're going into Calgary, it'll show up, 2 days afterwards. But it's a very quick and easy logistical, easy to manage project. And it's very easy to drop into a project. We do a lot of value engineering where we are replacing glaze systems because of the cost of traditional glass and aluminum systems. Architects are switching us out using Kalwall instead of the glass just to save some money and also have a much higher performing system. So it is a very easy thing to switch the details on and have us take it over. So, yeah.
That's perfect. Well, thank you very much. Thank you both, David and Mike, for your knowledge and your professionalism. Thank you, everyone, for attending. This was a great presentation. This is our second Bibliotech presentation, and I'm happy to see that it was another success, and I hope that everybody on the call learned something. So we really appreciate you being there. So for those of you who have attended and for those who have signed up, we'll send a recording of the webinar. If David and Mike want to share any additional documentation, we can send that as well as a follow-up. So just remember to check your spam folders because sometimes it goes on there. And if you have not done so already, you can sign up for a free Bibliotech account at bibliotech.ca, where you can connect with hundreds of manufacturers and suppliers, such as Kalwall and Bravura, to assist with your project. We also send out a free monthly newsletter where we share exciting events like this one. So look out for the September newsletter where we pick out the upcoming events in the industry. You can follow us on social media as well. Our handle is at bibliotech.ca, Instagram, Twitter, LinkedIn, what have you. And we look forward to seeing you at our next event. So thanks again, Mike. Thanks, David. And thanks to everyone for participating. We'll see you next time.
Thank you very much.
Thanks, guys.
Bye now.